one.
Well, this is a mess. Much better. Oh, hold on, we're missing one more thing. Perfect. All right, if you have no idea what you're looking at right now, that's perfectly fine. This is a spooling station that I made for my neighbor, and it's needing a massive upgrade. We decided to use a stepper motor on the inside of here, so let me take that off in a flash. All right, so here's the guts of what's going on the inside. You can see we have two pillow bushings that's running the shaft, and that's keeping everything straight and aligned on the back side. We have a regular pulley, and then the stepper driver, or the stepper motor running to the stepper driver, running to the stepper controller, running up into this separate breakout board, which had the potentiometer on the top and on-off button and reverse button. So the system's great, but unfortunately, if you know the downfalls of steppers, the torque falls off when you get up to higher RPMs. So instead of me re-gearing this into something that will be useful, we wanted to actually do a foot pedal system. So I picked up online a cheap servo motor for a sewing machine. So what we're gonna do is basically gut this thing, take the electronics out, take this motor, and hopefully do a swap in there. This bracket probably has to be ground off and redone in order to fit the new motor, but yeah, that's what this video is going to be about. Just upgrading the nice little motor here and getting this thing back to commission. Alrighty. Well, all the guts are out finally. And yeah, that's our slate that we have to work on. And you could see I totally messed up my alignment with that bolt. So it's actually just attached to the backside there, but yeah, for what this is doing, that's fine. So anyway, we gotta mount this bad boy right into here. So yeah, we might be custom making some brackets here.
Okay, so I went over here to Fusion 360 and started sketching out the outline of the servo motor, as well as some features. There's an extra little raised edge bevel that I want to do some clearance, and then as well as the shaft diameter. This is actually a clearance hole that goes around the shaft. The shaft would be another circle in here. Here's the mounting location, so I want these holes drilled out appropriately as well. And then moving on here, just going to go along the timeline. We just went ahead and drew up all the features, including the recess in order for this to go flush against the stepper. I also included some extra clearance items here just to basically make sure that I wasn't going to run into any of the jaws for my vices on my machine. So I set that up in here as more or less showing where that was, as well as the parallels that I use on my machine. I didn't want to cause the machine to end up destroying any of those parallels because the holes are so close to the edge on this piece. Went ahead here and I'll just slide her over. The final hole locations, these are for the bracket that I currently have on the machine that I'm trying to adapt this plate to. So I just went ahead and made this setup. Go here over to manufacture, and I created a few different milling operation programs, more or less the adaptive clear that you will see on the video here. I did have it set up as some type of 3/16 ball end, but I did use a flat end mill, so that's probably why this looks a little different. But that doesn't really matter. And then also a drill and bore operation in order to make those. Again, just trying to ensure that any of the holes on the backside you can kind of see would be very close to those parallels, so that's why I wanted to model those in as a separate type of attachment fixture piece, so the machine does not run into that. All right, let's go to the machine and start carving this out.
Alrighty, so you saw a video of the CNC going, which was creating this adapter plate in order to get the larger size servo drive to match up with the stepper motor bracket that I had originally put on here. I did have to widen it up a little bit because of the pulley. Unfortunately, when I put the pulley on here originally, it was going to interfere with this bolt. So you also saw on the lathe me making this little bushing that slides right into there. Then I had to trim down this little keyway a little bit, but no big deal. Pop that into place. There we go. And then my pulley, I had to take down the sides on the lathe, and then as well as create like a recess. And you'll see here in a bit, throwing that onto here. Okay, with the keyway on there. Then the recess was needed because we need to put a lock washer into there. And then finally put on the nut. And when that's tightened all the way down, it's basically flush, so we're good. So the pulley then will attach to this, and if we need to put some type of belt tensioner, we'll do that once the belts come. I ordered a few different sizes, so we'll see which one kind of works with this.
All right, so I just want to talk about the wiring and more or less talk about the potentiometer and really try not to butcher this because I'm sure I'm going to misspeak. So again, leave the comments down below if you want to correct me on this. But ultimately, a potentiometer is going to be working off of two principles. One is a resistance or transducer in most of these cases with an output that is more or less sliding along the potentiometer. So you have a volt in going to ground, and then you have an output. Based upon where its location is, though, is going to give you the type of resistance, which ultimately the controller is using as a speed input. So in this case, we have two different types of potentiometers. We've got what you see on the screen here, a rotary, and then as well as in the foot pedal, it's a linear potentiometer. They both work on the same principle. The resistance, though, could be slightly different between the two, but I have picked a potentiometer that matched the same resistance as the foot pedal was. So when you're wiring this up, just take in mind when I say I'm disconnecting one wire, it's mostly the output wire, and I'm controlling what output device is giving me the resistance reading off the potentiometers. So I put a switch in there, so later on in the video when you see that, the switch is actually on the output wire on both different potentiometers, and all I'm doing is selecting which output wire is providing input signal over to the controller or back to the controller. Since it's a direct connection, the VCC and the ground, it doesn't really matter about those two wires. It's really dependent upon the output and which potentiometer is providing said output based on that. So anyway, I just wanted to give you a quick discussion, or at least a heads up as to what exactly I was doing here.
Then as long as you disconnect one wire, the foot pedal. All right, so now we're back. I went ahead and put on a potentiometer and then a toggle switch, which is pretty stiff, but it will differentiate between the potentiometer. And then all I did was disconnect one wire in order for it then to run to the foot pedal. So the foot pedal plug goes right there, and this one is just flipping one out of the three wires for the potentiometer. Since both work exactly the same way, that's how that system works. Went ahead and moved and cut out the top portion here from the controller itself, and that runs all the way over here into the controller. So kind of lucked out with this motor and it being very simple, but figured I'd just give you guys a heads up and show you what it looked like before we kind of close this up and before we put the belt on to see how fast this bad boy will spin. All right, because I'm impatient, I just threw a piece of electrical tape on here as the belt, and this is 100 RPM, so you can see. And then for despooling purposes, if you want to run at 700 RPM, which this is completely changeable to what we need it, but yeah, it's probably going to have to get a different gear for that, gear it down so at least we can get a better low end speed, so at least you're not ripping line off too quick. But yeah, for the most part, this is almost done once we get the belt in and figure out if we need to throw a tension around here. All right. Desk is back to being a mess, but the belt came in and it fits perfectly on the pulley I ended up having to make. Had to make that out of stainless. Unfortunately, they don't sell a belt that's half, or a pulley that's half the size for that, for a 1/2 inch diameter, because you're only left with 0.2 of an inch with a throat. So yeah. So anyway, this seems to work. This is it at 50 RPM, even though the display is going to show 100 because it's geared 2 to 1. But yeah, works pretty good. It's 500 RPM, says 1,000. So yeah, I'm going to say this is all complete. I'm going to throw the cover on it, and we will see you later. Thanks for watching.